Welcome to this video where we'll explore Ohm's law, a fundamental principle of electricity named after its discoverer, Georg Simon Ohm. Ohm's law describes the relationship between current, voltage, and resistance in a conductor, and is expressed as the equation I equals V by R. This equation tells us that the current flowing through a conductor is directly proportional to the voltage applied across it and inversely proportional to its resistance. In this video, we'll use some examples to understand how Ohm's law works and how it can be used to design and analyze electrical circuits. Let's consider a circuit with a 2 ohm resistance connected to a 12 volts battery. According to Ohm's law, the current flowing through the circuit will be I equals V by R, I equals 12 by 2, I equals 6 ampere. Now, if we increase the resistance to 4 ohms while keeping the voltage constant, the current will decrease to I equals V by R, I equals 12 by 4, I equals 3 ampere. This shows that by increasing the resistance, the current will decrease, and vice versa. However, if we increase the voltage from 12 to 24 volts while keeping the resistance constant at 4 ohms, the current will increase to I equals V by R, I equals 24 by 4, I equals 6 ampere. This illustrates that by increasing the voltage, the current will increase, given that the resistance remains constant. It's important to remember that if any two quantities from I, V, and R are available, we can use the Ohm's law formula to find the third quantity. Ohm's law is applicable to all types of conductors, including wires, circuits, and other electrical components, and is widely used in the design and analysis of electrical circuits. Understanding Ohm's law is crucial for anyone studying or working in the field of electronics or electrical engineering. It can help us determine the appropriate resistance of a conductor for a given application or calculate the current that will flow through a circuit given a certain voltage and resistance. However, it's important to note that Ohm's law only applies to conductors that obey Ohm's law. Some materials, such as diodes and transistors, have more complex relationships between voltage, current, and resistance and do not follow Ohm's law. So, we must keep this in mind while designing and analyzing electrical circuits.